Yeah.
It's just for algebra.
It's what?
Algebra. The whole thing just is algebra extended. Where it's wrong looking, wrong website.
Okay. Let me make sure I gave you. Here's the code. And I mean, I just copied it right from his the email he sent. Lawson.al space 58386968. Is that what you had? Okay. And what did it come up with?
Algebra.
Pre-calculus algebra? Not.
Pre-calculus is algebra. Daily algebra.
Okay. That is, see, it was set up by a web-assigned person, works for Cengage, not me. And so he screwed it up, is what you're saying. Okay. Yeah. Yeah. I just love Cengage. I like this author, but boy, the rest of the things with Cengage is just so messy. And you see, I taught the class last term, and I said, he asked to use the same course. I said, absolutely. Last term, it was the right one. This time, how did he mess it up? I just can't figure it out. I will try to email him, but there is some sort of an access y'all have. They give you a number or email or something, don't they? The people in the last class said they did. So if you have a way to get in touch with them, call, write, complain, because this is really inexcusable. I'm sorry. Is it Caitlin? No.
Yes, sir.
Huh? Yeah, okay. Cynthia is not here yet. Ryan's not here yet. Bree came in. And Cody came in, right? Okay. Anyone else come in that I missed? I think I got everybody. All right. Was that true for everybody? Did anyone else check the code? Okay. I am so sorry. And I'm also sorry my projector is not working. This is not good. Was it on there at all before? Sometimes it just gets these. Okay. Let me see if there's anything. Ha. I guess it was the tilt of my screen. That is what was keeping it from working. So I will. The trouble is I don't have any office hours today to speak of, and I have some in the morning. So it'll probably be tomorrow morning from 8 to 10 before I'll be able to try to contact them. I might have some time tonight and email them tonight. But I'll try to get to that. But I say for y'all to start griping and complaining, because he got the information. It was all correct. And it was the same course I did last time, and there's just no reason for this screw up on their part. Because they did it all. I just sent them Math 113, chapters 4, 5, and 6, all sections, and it was just very straightforward. This course is the simplest of all the courses I teach, and like I said, it worked last time, and I do not know why it's not working this time. Did Cynthia come in? Okay. Ariel? Yeah. And patience, right? All right. Anyone else whose name I haven't acknowledged? Okay. All right. Let me try this again. Okay. Now, the discussion has been about the wonderful WebAssign, okay? It's taken me forever to get them to respond, and now they've responded completely wrong. But right now, what they sent me, they told me this class was set up under this number. Now, they may change it I don't know what they're going to do, but just so you'll have the number, let me get my pen set up. Lawson.al space 5838 space 6968. Okay. Now, just for my reference when I'm emailing the guy, was it even this book? Do you know? Was it even this book? Not this book. Was it some other book, I take it?
Intermediate algebra.
It's what?
Intermediate algebra.
Intermediate algebra.
Yes.
Okay, now I know what they did. Okay. I taught intermediate algebra last term, and he pulled up that one, though this isn't, you know. So I think I know what he did. Plumb laziness and no attention to detail, but that's what he did. So I will, was it the Hoffman book, or do you know?
I don't really know.
Okay, yeah. I think that's what he did. Hopefully the same number will be good when he fixes the thing. But the guy from Cengage, the expert from Cengage and WebAssign, he's the one that set this up. I told him what I want to set up and bring it over from last term. He brought over the wrong course. So I will get back in touch with him if I can today, but if not, it'll be tomorrow morning. All right. Sorry about that. Aggravating. And what's more, I sent him doing 112, 113, 125, 126, 127, 227, 237, and 238. Sent him 7 courses and said, please set them up. Some of them were from last term, some were not. This one's the last term and should have been the easy one. And he sent back and said, are any of these from last term? I said, yeah, and I told him which ones. So then he says, I'll need more information on one of them. I sent him all the information, but I sent it to him again. And so he said, well, I got them all set, and you know, I got 4 courses. 112, 113, which is wrong, and 125. The 4 that I did last term, except he sent me the wrong one. I said, well, how about the other 5? And he hasn't responded yet. So he's not been very good. And what I really would love for y'all to do is complain and gripe and get on these people's cases, okay? I don't even mind if you go to the bookstore and complain and gripe, though the bookstore has nothing to do with it. I want them to know Cengage is not giving decent service at all. So I want everybody to hear this. So feel free to gripe to your heart's content, you know. Gripe to me too, but I'm doing all the griping I can as well. All right. Sorry. Hopefully this will get fixed. But at the rate they're doing, maybe by midterm. No. I requested this very early in the term and just got it this weekend. I don't know how long it's going to take them to finish. Okay. Any other questions? Sorry about the mix-up. All right. We're in Chapter 4, Trigonometry, 4.4 Trigonometric Functions of Any Angle, and we did Example 1 last time. This is the end of it here. Examples 2 and 3, I don't believe are on the PowerPoint, so let's begin there. Example 2. Given that the tangent of some angle theta is equal to minus 5/4. And they give you one other little piece of information, that the cosine of theta is greater than 0. With that in mind, find the sine of theta and the secant of theta. How would you proceed? Someone give me a guess. What would be something you would do first? Does the name Waldo come to mind? No. Okay. What would you do? Second?
Set up a triangle.
Set up a triangle. Sounds like a great idea. Can I set it up on a coordinate axis? Would that be all right? Okay. Now, one reason I did that before I did it, I want you to tell me, where are we? That's why Waldo came into mind. Where are we, folks?
The fourth quadrant.
Why are we in the fourth quadrant?
-5 fourths.
Okay. One reason is the tangent is negative. Okay. Well, tangent is negative either in the second or fourth quadrant. So the fourth quadrant was a good 50% chance guess, unless you thought something else. What else? Cosine is positive. Well, cosine is positive in the first quadrant, but we can't be in the first quadrant because tangent is negative. Where else is cosine positive? In the fourth quadrant. So yes, these two pieces of information tell you you're down in the fourth quadrant. Okay? Now, you say set up a triangle. Good idea. What triangle would you do? You're in the fourth quadrant. So here, the y is going to be negative and the x positive. Okay? Now, focus on tangent theta. What is tangent theta? Y over x. Okay? So the y must be 1, 2, 3, 4, 5. That's a -5, and the x must be the +4. So here's where we are, Waldo, right down here. Okay? All right, that's kind of our triangle without closing it in. Here is the angle. Whoops, that's yuck. How rotten. Okay, let's try that one over. Here is the angle theta from the positive x-axis to the terminal line. Okay? There's your angle theta. And this here is, and you can either do the triangle this way, 5 and 4, or you could do it this way, 5 and 4. Okay, 4. Say again?
You just did the line of symmetry kind of. You just cut it in half.
Not in half. I did 5 down. Jake told me y over x, and you know in the fourth quadrant y is negative, x is positive. So it's a -5, 1, 2, 3, 4, 5, and then right 4, 1, 2, 3, 4. So that's what
Okay, you made it out.
yeah, that's what determines that. All right, everything's good so far, except how do I get sine theta out of all that mess? What can you tell me about sine theta? Y over r. Well, we know our y, don't we? Yeah. So sine theta, yes, sine theta is y over r, and we already know the y is what? -5. We don't know our r, though. And no way to get it either, is there? We're sunk. Nothing, oh, what? Of course. So the r is equal to the square root of x squared plus y squared, which is the square root of 4 squared plus a -5 squared. Oh boy, that negative in the radical, that's going to mess things up, isn't it? Please say no. What does that give you? 16 plus 25. Positive 25, by the way, and this is the square root of 41. There is your r. Oh, I forgot to do my plus or minus. Didn't I? Or did I? R is always positive. No, you don't do a plus or minus. So, Lindsay's here. All right. Okay. So here we have it. Done. There's our sine theta. Now, if any of you don't particularly like having radicals in the denominator, you could rewrite that as what? -5 root 41 over 41. If you prefer that form, it's fine. But they're both negative, and either -5 over root 41 is fine with me, or -5 root 41 over 41. But we still haven't done secant theta. Can you even do secant theta? What is that? R over x. I think we can. What will that be? Square root of 41 over 4. Done. Boy, I wish I could make it harder. I've tried and tried. I can't figure out any way to make it any harder than this. So, sorry. Does that make sense? Okay? Your little triangles, that works. But good idea is start by figuring out which quadrant you're in. And just telling you tangent theta would not tell you. That gives you one of two quadrants. Giving you what the cosine is at that same angle theta, just as sine, S-I-G-N sine, that then narrows it down to exactly which quadrant you have to be in. Then draw your little triangle and go from there. Okay, good deal. Any questions? Does this make sense? All right. That was example 2. Oh, and if you did want to plug in values, and they did, they left it -5 over root 41. Up to now, they had always been rationalized as a denominator. No longer, though, but they may go back. And they actually did a calculation there and found out that, and this is important for sine, this is 5. This has to be greater than 5. So the square root of 25 would be 5. This is square root of 41. The denominator's got to be greater because the radius is always greater than either one of the legs. Or hypotenuse, or whatever you want. It is the hypotenuse. It's always positive, and it has to be greater than that. But down here, this has to be greater than that because secant is always greater than 1, greater than or equal to 1, or less than or equal to -1. Can't be in between. And sure enough, root 41 is a great deal larger than 4. Root 16 would be 4. So, yeah, both of those make sense. Secant's positive because cosine was positive, right? Secant is reciprocal of cosine, so it's be positive. Everything works out well. Any question? Okay, there is a checkpoint. Please do the checkpoint soon after class as you can. All right, example 3 also is not in the slideshow. All right, for me to erase everything? Some people still writing. You okay? Okay. All right, so let's move on to example 3. Evaluate the cosine and tangent functions at the quadrantal angles. What do we mean by a quadrantal angle? One that defines a quadrant, in other words, one of the two axes. Okay? So evaluate the cosine and the tangent functions, okay, at the quadrantal angles 0, pi halves, pi, and 3/2 pi. Okay, that's the 4 of them. Can't do much else. So what's cosine of 0? Anybody? Cosine 0. Okay, is x over r. Okay, if you want to draw your little thing here at 0, here's the x. Let's just name it 1 because we don't know what else it is. What's your radius? Also 1. So that would be 1 over 1, which is 1. Okay, got it. Okay. Do you want to go on and do tangent at the same time? Tangent 0 is second y over x. I already figured out what x was. That's 1. What's your y there? 0. So that would be 0. Perfect. Okay. Let's do cosine of pi halves. What's cosine of pi halves? Radius is 1. Got it. Okay, that's your denominator. And the x would be 0. So that would be 0. What's tangent of pi halves? Anybody? Tangent of pi halves. 1 over 0. Oh, one of my favorite numbers of all time, which is completely undefined. Can't do it. Okay? Let's do cosine of pi. Okay. Now, I started just drawing a triangle that you can't see. But actually, the better thing would actually, let's put the coordinates in. And let's just use radius 1, because that's what we're using. What's the coordinates of this point here at 0? Second? Okay. Yeah, that one right there. 1, 0. Yeah, okay. A couple of choices there. Okay. What's the one up here? That would be 0, 1. And the one over here? Negative 1, 0. And the one down here? 0, negative 1. That may help. So what's cosine pi? Anybody? Negative 1. What's tangent of pi? Zero over negative 1, which of course is 0. Okay. And cosine of 3 halves pi. 0 over 1, which is 0, and tangent of 3 halves pi. Second? Undefined, right. Okay. Because you're negative 1 over 0. Can't do it. Okay? So, when you can't do a triangle and the quadrangle angles, you really can't. So just identify them. They're pretty easy. And if they don't give you a radius, assume 1. Figure you're back on the unit circle or something. You were used to 1. So that'll be just as good as any. And then pick your coordinates, plug them in. Knowing that if you choose the unit circle, the radius or the hypotenuse is always 1. Always positive in 1. All right, does that make sense? Let's see what they got. Oh, I think they got them right. Good for them. All right, good deal. Any questions? Checkpoint there too. Please do your checkpoints. If you can't figure out the checkpoints, audio-video solution at larsonprecalculus.com that you don't need a code for or anything else. And it'll be the right book. Okay. Almost guaranteed. Any question? All right. Let's move on to reference angles. Okay. I think we have done all the rest of it. Yeah. Okay. I just went back to find the space. Now, what do we mean by reference angle? When you're over in these other quadrants, other than the first quadrant, your angles are obtuse and really obtuse. You know, I mean, that one was way over in quadrant 4 that we did number 2. Those are just messy angles to mess with, and I don't like to memorize and keep up with what the values are. So what you can do, the values of the trigonometric functions of angles greater than 90 or less than 0, any negative angle there, or obtuse angles to greater than 90, they can be determined from their values at corresponding acute angles. Yeah, I like those little acute angles. Okay? And these are called the reference angles. So here's a definition of a reference angle. Let theta be an angle in a standard position that's starting at the positive x-axis and going around either counterclockwise for positive angles, clockwise for negative angles, and you can go around lots of times around anywhere you want to in the plane. Okay? Any old angle in standard position. Its reference angle is always an acute angle, and it's given the title theta prime. That stands for reference. Some texts use theta r, some r, or something like that. You'll see different things. This book uses theta prime. Formed by the terminal side of that angle we had earlier was one down here, remember? Okay? That side and the horizontal axis. So I don't know if I think I erased it all. So anytime you have any angle anywhere in the three quadrants that are not the first quadrant, then put that terminal side in, find the horizontal axis from that terminal side. Okay? The reference angle will be that angle from the horizontal axis to the terminal side of theta. That's it. And it's always acute, always positive, okay? Positive acute angle. Okay, that's the reference angle, theta prime. Okay, here are some examples. In quadrant 2, if this is your angle, theta, here's your reference angle, theta prime. Here's the terminal side, find the horizontal axis. That angle is the reference angle, theta prime. Quadrant 3, here's your reference angle. Here's the terminal side. Find the horizontal axis. That's your reference angle. Always acute, always positive. This one, you're in quadrant 4. You go all the way around here for theta. Find the horizontal axis from your terminal side. That is your reference angle, theta prime. Always acute, always positive. Now, they give these little formulas, and they're fine. They're absolutely correct. But to me, it's easier just to look at it and see. Well, this is the 180 line. Here's the angle theta. You're not quite there, so the difference between 180 and that angle, that would be your reference angle. Or if you think in terms of pi, which I like to think in terms of pi, it's pi minus theta. So either one of those will work. That's your reference angle. Basically, just look at the graph. Look at the graph of it and figure out what it is. It's the difference between those. Okay? Over here, though, it's the difference between theta and pi or 180 degrees. Because this has already overshot that. By how much did it overshoot? The difference between theta. So here you just reverse the two because the theta is the greater angle. Because you have to have this reference angle be positive. So it's the greater minus the lesser. So it's the reference angle theta minus 180 minus pi. Okay? I wouldn't memorize these formulas, but if you're into memorization and you like it, go for it. Over here in the fourth quadrant, the horizontal axis is up here. You're short of 2 pi or 360 degrees, so subtract this angle from this angle, 360 or 2 pi, and that will give you your reference angle. Again, the larger angle, which is the 360 or 2 pi, minus the theta, that will give you a positive reference angle. Always acute. Does that make sense? If you want to memorize the angles, fine. The formulas, that's fine. I don't ever mess with that. I draw the picture and say, okay, how do I find this? Subtract that angle from this or this angle from that, whatever, to find that reference. Always positive, always acute, always with the horizontal axis. Always. Does that make sense? How about, they left off the first quadrant, though. What's your angle in the first quadrant? The reference angle. It would be theta. Because it's already acute and it's always positive, okay? So in the first quadrant, the reference angle theta prime is equal to theta. They didn't put that one up there because I guess they thought that's intuitively obvious. So let's do example 4 here. Find the reference angle theta for theta equal 300 degrees. Where are you, Waldo? Angle 300. Fourth quadrant. So where's your closest horizontal axis?
2 pi.
Yeah, directly above you. But I wouldn't use 2 pi here, though I love pi. 360, and what would be your reference angle? Theta prime.
60 degrees.
Yeah, 60 degrees. The difference between this angle and 360. The positive difference, okay? 60 degrees. Uh-oh. What in the world is B?
It's in radians.
What? Oh, yeah, you don't see a degree symbol? It has to be radians. 2.3 radians. Ugh. Where are you, Waldo? Second?
Quadrant 3.
Quadrant 3. Why do you say that?
It's just short of 2 pi.
Short of 2 pi. Is that what you said? Pi. Yeah. Yeah, you're right. It's short of pi, but that would put you in not 1, 2. Okay, yeah. How about 4? No, okay, all right. Yeah, quadrant 2. Because you're greater than pi halves. Pi halves is about a little bit more than 3 halves, right? Because pi is a little bit more than 3. So 3 halves would be 1 1/2 and some change. So you're past that, but you're not as far as pi, which is 3.14. So you're not that far, so you've got to be in quadrant 2. So all you can do is approximate this. Well, written exactly, your theta prime is what? You're in radians, so you better stick with your pi minus, no, not 180, don't, yeah, that's degrees. So pi minus 2.3. Well, since they gave you a number, let's use pi of 3.1 minus 2.3, and that would be 0.8. Now, they're going to do a lot more digits than that. With being a math book, I guess they can. But if this were a physics or anything that really deals with measurements, you can't get more precision out than you put in. You only have 2 digits here, and in subtraction, you can't add another digit in there. It just comes out 0.8. I bet you in the book they do 0.8416 or something like that. You know, a lot more digits than you really can justify here. Okay. How about C? Ooh. What's your theta prime here? Good thing to figure out is where in the world are you? Anybody?
Third quadrant.
Second?
Be in the third quadrant.
Third quadrant. How did you get that?
You go clockwise.
Clockwise, and that would be to, this is in degrees, so that would be to 90. And all the way up here would be to minus 180. You're not that far. You're between minus 90 and minus 180, so you're third quadrant. So what's your theta prime?
Negative 45 degrees.
Yeah, okay. But not negative. Always positive. 45 degrees. Okay? It's the difference between negative 135 and negative 180. So the horizontal is 180. Who cares what the signs are? Just make sure you get the absolute value of that difference. Okay? So that will be 45 degrees. Perfect. Any questions? All right. Let's see how the book did them. They used the formulas, which are fine. We did too, sort of, you know, except I didn't think about the formula. I said it's in the fourth quadrant. So the horizontal line is going to be 360, and the difference between 300 and 360, the positive difference is 60. That's how I do it. Now, that may be sloppier than what they're saying, but that to me gets it done. Okay? And that, of course, would be 60 degrees. Degrees. Okay, good. And here's the figure. And 300 degrees would be past 90, past 180, past 270, 30 degrees, past 270, which is 60 degrees. 360. 60 degrees. Always positive, always acute. Always with the positive x-axis. Okay? Oh, no, with the x-axis, horizontal axis. Okay. Second one, 2.3. Because there is no degree sign, you know that it has to be dealing with radians. And 2.3 is something in between pi halves, which is 1.5708. I said a little bit more than 1.5. And pi, which is 3.1416. Approximately. These are all approximate, okay? It follows that you have to be in the second quadrant because you're between pi halves and pi, and second quadrant, and pi is your horizontal part, so it's the difference between pi and 2.3. That is the exact answer. Of course, we don't usually live with pi's, we usually live with numbers, and they put 0.8416, which how do you get 4 digits of precision out of a problem that only had 2 digits of precision going in? You can't really, so they did it anyway. Okay, either one of those would be correct answers for me. Okay, any questions? And they put radians because it doesn't have a degree sign. All right, and here's a figure showing that. If this is 1.57 up here, this is 3.14 down here, then 2.3 is somewhere in between there, and the difference between 2.3 and the pi, that is your theta prime right there. Positive difference between those. And that happens to be. Okay. For C, first determine that minus 135 is coterminal. Well, yeah, you could do it this way, but why do the extra step? Why not just say negative 135 is between negative 90 and negative 180? That does it just as well as in finding out the coterminal angle by adding 360 to that. That works, gives you 225, and you're still in quadrant 3. You can't help but be in quadrant 3. And so the reference angle is the difference between either 135 and 180 or between 225 and 180. It doesn't matter which one you use. You don't have to do the coterminal angle. Just keep up with where you are. And that difference is 45 degrees. Degrees. Okay. Make sense? Any questions about it? Not really all that hard. It might take a little thinking. Remember, your reference angles always with the horizontal axis, always positive, always acute, between 0 and 90. Always positive. All right. And here's a picture of it. The negative 135 puts you over here, so why not just do the difference between that and negative 180? I mean, that's the horizontal axis. It's always a positive difference. Subtract it any way you want to, it's going to be 45 degrees. Or you could add 360 to this, you get 225, and then subtract 180 from that, you get the same thing. It's just extra work. Frankly, I'm lazy enough not to want to do extra work. Okay? So knock yourself out, whichever way makes the most sense to you. Okay. Any questions? All right. That was example 4. Now we're doing trigonometric functions of real numbers. I thought that's what we were doing. Now, when they say this, they're saying as opposed to degrees. Those degrees are real numbers, but those have symbols on it. Real numbers would then be radians. trigonometric functions of radians. We've been doing those from the very beginning. So, let's see. To see how a reference angle is used to evaluate the trig function, consider a point xy anywhere in the plane, xy. Okay. This happens to be over in quadrant 2. On the terminal side of some angle theta. It could have been anywhere. It just happens to be that. Okay? Well, already you know that x squared plus y squared is r squared, right? So r is the hypotenuse, y is the opposite, and x is the adjacent. Know that. It's always true. Now, if you're dealing with the reference angle, which is what they're dealing with, that's the opposite side, that's the adjacent side. Okay? The reference angle is always acute and positive, so you want this to be positive and that to be positive. So therefore, they say absolute values. Perfectly fine. Correct in everything else. Here you didn't have to say absolute y because that was already positive up here. This one was positive, but the adjacent was the absolute value of x. Whatever that was, take the positive value of it. But the reference angle has these three. Opposite, adjacent, hypotenuse. Y, x, r. Same as before. There's nothing really all that magical about it. Okay? Now, I hope this doesn't confuse you any, but actually, if you just kept the signs with them, you'd have the things without even messing with the reference angle. Just think of the reference angle, but if this is negative, then all your things are going to pan out perfectly fine. It's just remember opposite, adjacent, and hypotenuse. R. It always works. X, Y, and R will work on any album, anytime, anywhere. But we usually don't think of the negative, so we use the reference angle to keep everything positive, because it's a nice little acute angle. Okay. So, by definition, you know that sine theta is y over r, tangent theta is y over x. For the right triangle with acute angle theta prime, and the sides of these absolute values, then the sine of theta prime is absolute value of y. Oh, they forgot to put absolute values on r, didn't they? They don't have to. Why? R is always positive, of course, okay? And the tangent of theta prime is the opposite over adjacent. There we need them both, okay? Because this is a positive acute angle, you need those to be positive, okay? It follows that the sine theta and sine theta prime are equal, except possibly for the sine, S-I-G-N sign. Because you see, actually these would be, because that y was already positive, r was already positive, they're going to be exactly the same. But the tangent wouldn't be, because x was negative in the figure we just had, and y is positive, so this is going to turn out negative. This will turn out positive, so except for the S-I-G-N sign, the values are exactly the same. That's the point, okay? So, in all cases, the quadrant in which theta lies determines the SIGN sign of the function value. So know where you are, know what sign goes with each of your trig functions, and just do it. So to find the value of trigonometric function of any angle theta, first determine the function value of the associated reference angle, which is always going to be positive, because any trig function of acute angle is always positive. And then figure out what quadrant it's in, and then give it the appropriate SIGN sign for that function value. If you're over in the second quadrant, sine and cosecants are going to stay positive. But all the rest of them are going to go negative. Third quadrant, only the tangent and cotangent are positive. All the rest of them are negative. Fourth quadrant, only cosine and secant are positive. All the rest of them are negative. So you just put this SIGN sign with the answer you got from before. You can greatly extend the scope of exact trigonometric values. Remember the ones we know and love? For instance, knowing the function value 30 means that you know the function values of all angles for which theta is a reference angle. So that would be 180 minus 30, that would be 150. 180 plus 30, that would be 210. And 360 minus 30 would be 330. All those are going to have the same numerical value, of all the trig functions. The SIGNs signs will change depending on which quadrant you're in and which trig function you're dealing with. That's all that matters. Does that make sense? It's fairly there, okay? So for convenience, the table below shows the exact values of sine, cosine, tangent for the special angles and the quadrant angles. And I think we've seen this how many times now? But it's important stuff, and that's why they keep showing it. 0 degrees is 0 radians, sine is 0, cosine 1, and tangent 0. On this side of the cosine. 30, which is pi 6, 30 degrees, pi 6. The sine is 1/2, the cosine is √3 over 2, and the ratio of those is 1 over √3, which is √3 over 3. They go back to rationalizing the denominator. Pi fourths, 45 degrees is pi fourths radians. That's √2 over 2, √2 over 2, and 1. 60 is pi third, 60 degrees is pi third radians. And then you just flip these two. It's √3 over 2 for the sine, 1/2 for the cosine. The ratio of that is √3 for the tangent. 90-degree angle, pi halves radians. The sine is 1, the cosine is 0, and therefore the tangent is undefined because you can't divide 1 by 0. And then when you get to it, you can add 30 to that, add 45, you can carry all the way through till you get to 180, and that's pi radians. Sine is 0, cosine is -1, and tangent will be 0 over there because 0 over -1 is still 0. And then when you get around to 270, down here, that's 3/2 pi radians. The sine is -1, the cosine is 0, and of course tangent. But you could step from 180 through each of these degrees, adding to it to get over the 270. And then step from 270 to 360 by adding all those angles to it. And you know every one of them. You just have to rearrange them and then put the SIGN signs in the right place. Know that table, okay? Don't sit down and memorize it. Get to know them like you remember your brother's name, right? You just use it all the time so you know it, right? So let's do something. Evaluate each trigonometric function. Cosine of 4/3 pi. Two pieces of information I'd like to know. Can anyone think of what one of them might be? What quadrant you're in? Where in the world are you? So with 4/3 pi, where are we? Third quadrant. Why? You're beyond pi. Pi would be right there on this side, right? So you're just 1/3 of a pi below that. So not 1/2 pi, 1/3 of a pi. So you're over in the third quadrant, okay? And what trig function are you dealing with? Pretty obvious. Cosine. And what's cosine in the third quadrant? Second? Negative, okay? So we know our SIGN sign already. That's going to be a minus, okay? Now, just happened to be that since we're in the third quadrant, we're referring to your past 180. Well, that's your horizontal axis, isn't it? How much past 180 are we? Or pi are we? 1/3 pi. So what's the cosine of 1/3 pi? Or pi thirds? Get to know them. Cosine of pi thirds. It's okay to look back. 1/2. There you have it. See what we did, and in whichever order you wanted to, we just decided to go with which quadrant you're in. That gave you the sign of the cosine, the SIGN sign of the cosine, negative in the third quadrant, and then pi thirds was your reference angle, and the cosine of pi thirds is 1/2, but with the sign of minus. That's it. I mean, that's how you do these, okay? You can think of all those words and the technique and the steps, but that's what you're doing, okay? How about the B part here? Tangent of negative 210 degrees. Where in the world are we? Yeah, second quadrant. Why? Going negative, that would be negative 90, negative 180. You got to go a little past that, but not up to 270. So you're how far past that? How far past 180 are you? 30 degrees. So this is the same. Okay, and since you're in second quadrant, what is the SIGN sign of the tangent in the second quadrant? Everybody agree? Negative. They don't agree. Okay. No. Tangent is positive in the third quadrant. All students take calculus. Tangent and cotangent positive in the third quadrant. Second, no. Negative. Okay? And so what's the tangent of 30 degrees? So it's minus the tangent of 30 degrees. Why don't I write it that way? That's pretty easy to do. What is the tangent of 30 degrees? Perfect. So this will be minus the square root of 3 over 3. And if you wanted to say negative 1 over root 3, that would have been okay too. See how it works? Know those trig functions of those special angles. Think through them, got them down. Okay, cosecant of 11/4 pi. What's one of the first things you need to determine? What quadrant are you in? What quadrant are you in? 11/4 pi. There's 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 7/4 pi. Boy, that's a long way to do it. Why don't we just divide 4 into 11? What do you get? At least the first number.
2 point something.
Okay. 2 and 3/4, right? So 2 would be 8/4. That gives you 3/4 left over. Well, 2 gets you all the way around here. So now all we have to worry about is 3/4. 1/4 pi, 2/4 pi. 3/4 pi, where are you? Second quadrant. What is this cosecant in the second quadrant? Positive, because it's the reciprocal sign, and sine is positive in this. So we got our sign, SIGN sign, okay? And so that would be, in fact, since we have the sign, why don't we just do this? Because I know sine better. It's 1 over the sine of, what's our reference angle? Second? Okay, yeah, but the reference angle for that. Okay, remember we said we only needed 3/4, 1/4, 2/4, 3/4. Of course, the 3/4 is still a 3/3 top. No, never mind, that's something else. Okay. So what's your reference angle there? Pi over 4. Okay. And what is the sine of pi fourths? Is what? Okay. Now, I'm not going to rationalize that one. I'm going to put 1 over root 2. That to me is a lot easier to deal with. That is square root of 2 over 2, by the way. So what you reckon that is? Square root of 2. Reciprocal over reciprocal is root 2. Does that make sense? First, we determine the quadrant. Yeah, that makes sense. positive there. But cosecant is always greater than or equal to 1. And root 2 is 14414, blah, blah, blah. It's greater than 1. I feel really good about it. Warm and fuzzy all over. Okay? Make sense? You okay with it? Okay. Let's see how they do it. Because 4/3 pi is in quadrant 3, exactly like y'all determined, and the reference angle is pi thirds. We determined that too. And when we said it was in quadrant 3, and we're doing, I think if I'm remembering right, a tangent of that. No, it wasn't tangent, it was cosine, wasn't it? It would help to be on the right page. Yeah, cosine of that. Then cosine is negative in that. So I want to go and write my minus sign down there. That's just me, okay? And then you have to figure out what the cosine of pi thirds is. And we determined that to be 1/2 with a minus sign becomes minus 1/2. Moreover, the cosine is negative in quadrant 3. So cosine of 4/3 pi is minus the cosine of pi thirds. There's a reference angle, and that would be minus 1/2. Perfect. Okay. Minus 210. They love to get the coterminal angle, and if you like that too, go for it. Okay. But I see no problem with doing minus 90, minus 180, minus 210 is somewhere up here in quadrant 3. The second quadrant puts you right there, and that's 150. That's right, but if you do it this way, you're just 30 degrees past 180. So there's your reference angle right there. So you don't have to first get a coterminal angle, then find this reference angle. It just seems like that's extra steps. But if you like it that way, go for it. It's correct. So the reference angle is 30 degrees, which you could have done that way, or done the absolute difference between minus 260 and minus 180. That gives you 30 degrees as well. Okay? And I can't remember which angle we were doing with tangent on this one, wasn't it? Yeah. Okay? And tangent in the second quadrant is negative. Okay? And that would be minus tangent of 30, and tangent of 30 is root 3 over 3. So it's a negative root 3 over 3. Perfect. Just the way we did it. Close anyway. All right. The next one, 11/4 pi is just such a big number. I divided, they subtracted. It doesn't really matter which one you do. Subtracting may be a little cleaner in some cases, but dividing to me is a little bit easier. But whatever, floats your boat. So that would be 3/4 pi. So since you're starting with 2 pi, just subtract that off. 3/4 pi will be 1/4, 3/4. That puts you in second quadrant angle of 3/4 pi, which would be reference angle of pi fourths. And we're doing with cosecant, which is the inverse of sine. Sine is positive in the second quadrant, so is cosecant. So that would be the reference angle is pi fourths. Yeah. They did it fine, okay? And because cosecant is positive in the second quadrant, you have the positive value of that, and that's 1 over sine of pi fourths, and that would be root 2. They skipped the other parts and just put a root 2. Any questions? Positive because sine is positive in the second quadrant. Man, they have us ending the section right there. Well, we still have example 6 and 7 to go, so let's do those if we can. This class just flies by so fast. Okay. All right. So let's back up and do example 6. Let theta be an angle in quadrant 2 such that the sine of theta is 1/3. Sine of theta equal 1/3. Okay. Now, it says find cosine theta and tangent theta by using trigonometric identities. Okay. That may not be pure math, but it's saying what it is. Theta is in the second quadrant. Okay. Sine theta is 1/3. Okay. Where would you begin? How would you approach this problem? There's several ways you can do it. They say using trig identities. If you find that awkward, you don't have to use it. But if you find it the way to go, use it. Perfectly fine. What way do you see as a good way to go? What's our current definition of a sine? I say current because we've had several. We've had unit circle definitions. We're not necessarily on a unit circle now. Don't force yourself to be there. Then we had acute angle definitions. Well, we're not got an acute angle. We're over in quadrant 2. What's the most generic and general definition for a sine? One that we were most recently using. Say again? Y over R. I like that one. So this is Y over R. Now, what does that make us? I like pictures. What is our radius then? 3. So do a 3 circle, not a unit circle, a 3 circle. I don't know if that's what you really name them, but that's what I name them. Okay? So, my circle, my tick marks are not very good and my circles are terrible. Okay? You're in the second quadrant and the sine is Y, which is 1 over R. So here Y is 1 and here's your R is equal to 3 and Y is equal to 1. Approximate anyway. Okay? How can you get cosine of theta? That's x over r. Now this is my way of doing it. If y'all like to use the trig identities, knock yourself out with them. They work. They work really well. Okay? But we already know what r is. That's 3. And I know the SIGN sign of x. What's it? It's negative. Okay? We just need a value for it. Well, I know something about the value. It's between 0 and 3. Okay? Pretty obvious that too, isn't it? How do I get what the x is? Pythagorean theorem. And what would that be? X is equal to, second, square root of, second, 9 minus 1. 3 squared is 9. 1 squared is 1. So this is, oh, it's a minus the square root of 8. Now, if you want to be real picky about it, that could be minus 2 root 2. If you wanted to be real picky about it. I don't know if you do or not. Okay? So we already got the minus sign in there. We don't need that again. So this is 2 root 2. Isn't it? Over 3. Now, the only thing I worry about is 2 root 2 greater than or less than 3. If it's greater than 3, we did something wrong. It's got to be less than 3. But put it on your calculator, see what you get. 2 root 2. times the square root of 2. Yes, very good. And yeah, even my picture almost looks like that could be true, 2.8 or something like that. So yeah, that's something less than, greater than negative 1. Okay, it's absolute value is less than 1. All right. Can we do tangent? What is tangent? Y over x. And we already knew what y was. We assigned that as 1 over x was a negative 2 root 2. If you don't like having radicals in the denominator, you could change that to be a minus root 2 over 4, right? Multiply this by root 2 and that by root 2, you get root 2 up here, and root 2 times root 2 is 2 becomes root 4. Okay. Tangent and cotangent can be any values at all. This is a very small one because y of 1 over a bigger number, 2.8 or something like that. But it's negative because you're up in the second quadrant. Does that make sense? Okay. Let's see how the book did. They got cosine theta equal minus 2 root 2 over 3. Good for them. And tangent theta negative root 2 over 4. Hey, pretty good. There is a checkpoint. Please do your checkpoints. Okay? Best way to reinforce what we just talked about. And now, as if I haven't been encouraging to do so already, we're going to be using a calculator. Okay? Do we have time? Oh! Let's see if we can get it done real quickly. Use a calculator to evaluate each trig function. Cotangent of 410 degrees. Okay, use your calculator. Find the cotangent key. Any luck? There is no cotangent t. What do you do? Okay. Do tangent of 410 and then do the reciprocal key for that. It would be x to the minus 1. Is that yours? Okay. 1 over x, whatever it happens to be. Or if you just wanted to do it the old-fashioned brute force way, 1 over tangent of 410 degrees. But what's the first thing you do before you do any of that? Make sure you're in degree mode. Okay. And once you're in that, you can go to town. You don't have to figure reference angles. You don't have to see which quadrant you're in. The calculator does all that for you. Isn't that nice? Okay. But it's still a good idea to know whether your calculator is giving you a right answer or not. What quadrant are you in if you're at 410 degrees? Second? First quadrant, because you're just past 360, 50 degrees past that. So you're in the first quadrant. That should be positive. Everything should be positive there. What do you get? Anybody? Did you do it?
First one, 0.839.
Yeah, very good. Okay. The second one here is sine of negative 7. Ah, yes, you've got to be in radian mode. And once you're in radian mode, all you have to do is punch that in. But let's just get an idea of where we are. Negative 7 would be, negative 5 would be negative 3 over here, negative 6.2 over here. You just passed that, so I'm guessing you're in, wait a minute. Yeah, you're down in quadrant 4. And sine is what sine in quadrant 4? Negative. So I hope you're going to get a negative answer. Do you?
Yes.
Yes. And I hope you get something greater than negative 1. Yes.
0.65.
All right, good. That's what they got in the book too. And then the last one is secant of pi ninths. Okay? Where are you, Waldo? And by the way, your calculator will do this for you, but what's the first thing you check on your calculator? You're in? Which mode? Radio mode. You already were in it, so that's good. And you can just do find the pi key, divide by 9. Oops, where's your secant key? Your reciprocal key for what? Cosine, okay. Or you could do 1 over cosine of pi ninths. But you know you're in the first quadrant because pi ninths is in the first quadrant, and that's going to be a positive value. Less than 1 or greater than 1? Greater. See, because they're always, never, they're less than 1. Oh, well, unless they're very negative. But in the first quadrant, this is positive. So it's got to be greater than 1. And what does that give you? 1.064, is that what you said? Yeah, that sounds good. All right, good deal. There is a checkpoint there as well. Okay, we didn't go over too much, did we? There is a checkpoint. Here's the checkpoint. Do we have time for the vocabulary? Yay or nay? No. Okay. Do we want to start with vocabulary next time or start with 4.5? Vocabulary. So we'll start with vocabulary next time. But because we did finish 1.4, it is test time. You've all been looking forward to this, right? Okay, I just got to find the right class. Ah, here we are. Okay. Boy, I didn't realize what a big class I have. I don't think I've ever had a trig class this big, so y'all are first. You're sure you don't want to go back and do class tests? Since we're that big? Oh, you don't have that big. All right, tap on the back a couple of words if you can. And take 1 and pass 2. Take 1 and pass 1. Take 1 and pass 2. Technically due next Tuesday, but you don't have to get them in that soon. If you need more time, you certainly have it, but just don't go past till when we finish the chapter. Be sure you get it done before I give you another test. But if you can't get it done, that'd be great. The reason I give you next Tuesday, 2 reasons. One, that gives you Thursday. If there's anything on here you don't understand what I'm asking about, you can certainly ask me questions. And second reason, you always have a weekend to work on it. So, but you can take more time if you need it. But for now, that'll be it. All right, good deal. We'll start with vocabulary next time and move on to 4.5. When we start graphing these trig functions, won't that be fun? Okay. The answer is yes. Okay. Good deal.